I say all the time, this takes many more clicks than I ever think it should. Okay, so there we go. This meeting is being recorded, and it is my pleasure to introduce Dave Williams. We have like I said, we have a kind of a special presentation, and we decided we're going to forego the introductions and bio because you know how much I like that anyway. But what we are going to do before Dave takes the podium, we have a little multimedia. That's why we got the mood lighting going on. And no popcorn. I'm sorry, Bill. All right, so let's stop talking.
That old book of yours is in shreds.
Same as us. Seen too much war.
Hey, Oakley. Don't worry, son. Them Yankee boys keep store hours. They ain't open yet. Close it up. Where'd you come from? Hey, that's fresh breakfast. He's mine, Butcher. Hey, you mine. Hey, come on. I saw it first. Get your balls over there, Rabbit. Get your balls over there, Rabbit. Now.
Good. Thank you. Thanks, Al. As Al said, my name is Dave Williams, and I've been a mining engineer and practicing it for, this year will be 50 years I've been a mining engineer. A little quick about me here and stuff, not much into the bio stuff, but I went to Penn State. I have a BS in mining engineering. I got out, worked underneath other mining engineers, old ones and stuff like that. Learned a lot of things from the ground on up. Surveyed anthracite coal mines, just about did everything and anything that you could think of in the anthracite region. Back in 2002, there was a summer accident out in Somerset with Q Creek. Governor Schweiker was the governor at the time. He set up what was called the Mine Void Commission, and he had testimony in Johnstown and then Pottsville. I testified in Pottsville, and the main part of my testimony was that scanning has come so far and stuff like that the state should start a program of scanning all the mine maps that they can get their hands on stuff. So it was my testimony and suggestion that started, maybe some of you guys use it, the Mind Map Atlas, the POSDA website. That was kind of my creation. So I'm into other things. I'm into history and stuff. I worked at the Pottsville DEP office as the chief mining engineer for 16 years, was in charge of the mine maps there and stuff. So been all over the place and stuff. So I also, I'm a board member of the Schuylkill County Historical Society, and history just intrigues me. And the program that I have here is my favorite one and stuff. A unit from Schuylkill County could have ended the Civil War 1 year prior to when it did end. And if you think about it, thousands more soldiers died after what I'm going to show you today the world probably would have been a lot different and stuff on both sides, the Confederates and the Union and stuff. So we'll get started on this and stuff. I want to start out. It was the 48th Pennsylvania Volunteers from Pottsville. It was a unit of about 400. There were 400 men in that unit. When you registered for to be a soldier and stuff, you had to give them some information. We've looked through that information. About 115 had registered as anthracite deep miners, a lot of them from the Minersville area and stuff. One of the guys that registered said that he was a expert explosive fella, so I'm sure he had a big part of this too. So. Okay, what am I doing wrong here? There you go. Okay. The leader of the 48th was actually a mining engineer. He was Colonel Pleasance and stuff. And he is the guy that came up with this idea and stuff. But a little bit of background on Colonel Pleasance, which is going to play into this story, is that prior to the war, he worked with the railroads. At that time, they wanted to get the railroad system from Philadelphia to Pittsburgh, but there was a big mountain in the way, the Appalachian Mountains and stuff, and it had to be tunneled through. So he helped with that venture and stuff. And one of the big parts about that was ventilating those railroad tunnels, that they had enough air and stuff that they could do that kind of work. So he learned a lot about ventilation tunnels just from that episode and stuff. So when I do a presentation, I try to get a resource, I try to get the facts, and one of the best resources for this is after the war was over, they printed volumes and volumes, and it was called the War of the Rebellion, and it was the official records of the Union and Confederate armies. They had gathered up all the orders and stuff like that, put them into this books, and it's a great resource to go over historical things like this. Okay, this happened down in Virginia at Petersburg. And the big thing about this battle was the Union had the Confederates hold up in Petersburg, and it was the last of their railroad system. And they knew that if they could get into Petersburg, break up the railroad system, that would end the war, because then the Confederates couldn't get supplies back and forth. So, but it was also the first very well-known entrenchment war. The Confederates had dug in trenches like we seen on the movie when it started, and the Union had to dig trenches away from them and stuff within about 300 feet in most cases, and the Union just could not penetrate the trenches. There was just, every time they tried an attack, they got slaughtered. The Confederates were very good marksmen and stuff, so it was kind of a stalemate and stuff. So this unit that was there from Schuylkill County, they decided, the Colonel Pleasance decided, we can do a tunnel here. And this is kind of where the geology comes in at first. If they would have been at Gettysburg or another place, it's solid bedrock. But here at Petersburg, it was shales and slates and what they call merle, and it's something that they could dig by hand. Another big part of this story, which we're going to get into, is that they didn't get much help from the higher command. The Army Corps of Engineers, there was a officer that was in charge of that, and him and Pleasance didn't get along. So there wasn't hardly any cooperation to help out this 48th unit to dig this tunnel. And it's really interesting to me how they came up with different ways and different methods to make this happen. So what you're seeing on the screen right now is actually a picture of the battlefield. And no matter where you're looking at it, it probably looks like spaghetti. It's just a mess and stuff. So I kind of simplified it here. And this is what the battleground looked like. The Union is on your right side, and the Confederates are on your left side. The trenches are drawn on this map, and the crater is right here. And right here, where the hand is at right now, was the entrance of the mine. The video that we looked at there didn't quite have it right. The Union had the low ground. The Confederates had the high ground. So in the low ground and stuff, they could see the strata that was sticking out of the ground, the different geological structure and stuff like that, the sandstones, the merle, all of that. And there was a little gully right there. The Confederates couldn't see what was going on. They were hidden because they were below the horizon. So the first thing that they had, once they came up with this idea, they took it to the command, and the commandant, Dwayne was the officer in charge of the Army Corps of Engineers. He didn't think that there was no way this could happen. There was never a tunnel in a battle that was driven as long as this one was driven, which in the end it was driven 510 feet. So he said this was absolutely preposterous. They called it claptrap and didn't want to cooperate and stuff. So they were given permission to start this because it was a deadlock right now. And they thought, well, at least they give the men some exercise, something to do. So they got started, but they needed a transit. And that's what a mining transit looks like. A mining transit has an auxiliary scope on it to the top there. Mostly because if you're surveying something that is on a straight pitch, straight down, or a dip greater than 65 degrees, that bottom scope will turn right into the plate and you won't be able to use it. But if you have a piggyback over the top, you can see over it, and then you make some engineering calculations for the change of the two scopes. But he needed one, and Dwayne had one right there at the campsite and wouldn't give it to him. So Pleasance's general was General Burnside. He had to send back to Washington just to get a transit. So this is the start of the no cooperation story here. So going back to my picture here, the first thing once he got the transit is he surveyed along the trenches of the Union side. He set up 5 survey points. The Confederates couldn't see him surveying because he was in the trench. So putting the 5 points in here and stuff, he got coordinates for all 5 points. And then they did have an officer come with him to show him, well, if this is truly going to happen, if you can really do it, this is where we want you to blow up the Confederate line at. And he pointed to a tree that evidently was up here where the X is at. And at the moment that he pointed to the tree and stuff, the guy got shot in the face. And, you know, those bullets weren't like they are now. They were pretty horrific when they hit a body and stuff. And somehow the guy survived. He survived the bullet shot to the head. So here's the start of engineering part of it and stuff. So what Colonel Pleasance would do is he would set up the transit in the trench, but he would set it up so that the telescope would just stick out over the trench, and he'd put a burlap bag over it for a while. And then he would get other soldiers that were in that trench and have them take their hats and put it on their top of their guns, and a distance further away, somewhere down here and stuff, he'd have these 5 guys hold up their hats, and the Confederates would start shooting at them. It was a diversion tactic. While they were shooting at the hats and thinking that they were killing somebody, he was taking the burlap bag off and getting his azimuth shot on that tree of where they wanted to go. And it worked pretty well, and he did that for each one of these 5 survey points. So now in survey work, what he's doing here is he's creating a triangle here. That's a triangle. He's creating a triangle here and a triangle here. He's certainly not going to be able to take a 300-foot measuring tape and cross this yellow line and say, hey guys, I'm surveying because we're going to blow you up and stuff like that. That's not going to happen. So he came up with this triangulation method here to try to figure out where is this point at. So he'd have a coordinate on it when he'd start the tunnel. So this is the basic geometry with a triangle. If you know 3 parts of a triangle, you can know 2 angles on a side, or you can know 2 sides or an angle. It's called the law of sines. You can figure out the whole rest of the triangle then. So that's what he did. That's exactly what he did. He had his angles here from inside the trench, and he had his distance here. So he was able to figure out the rest of it, to be able to figure out the geometry of exactly where that point was at. So now it's kind of interesting because nowadays we use GPS to survey. And when we use GPS to survey, it sends a signal from a satellite up to a satellite and down, and it takes multiple shots. And when it takes the multiple shots, it takes all of those and averages them together to come out to that one exact point. And it's kind of how this worked too, because he had different answers, but they were very close, but he had different answers on all these triangles and stuff. So he took that and did that same calculation and came up with the average of what is that coordinate. Then he put a survey point down here at the mouth of where they were going to start at, and then he knew exactly the direction that they had to go. So that's the survey part of it. That's the mining engineering part of it. So I've been there at the site. It's been a few years and stuff. They made a rendition of it. A lot of things caved since that happened and stuff. And this is a rendition of what the mouth must have looked like. When I was down there to look at it, they had bars across here, and this now also is a federal park too. The rangers said that they had to put the bars because in the morning they were seeing too many homeless people that snuck in there and spent the night in there. You'll also see something down here we're going to talk about. That's act like tubing and stuff. That's made out of wood. It's square and stuff. It's going to help with the ventilation of this mine. And you can see this is going uphill now. And that's a little bit better of a look at it. You can see the subsidence from where the actual tunnel went right there. So they started in with a tunnel. And this is some of Colonel Pleasance's drawings. And again, you guys are pretty far away. I have some bigger details of those drawings of what they look like. Here's the next thing. They asked for picks, miners' picks and stuff, and they weren't given. And these were close quarters and stuff like that. These dimensions here were pretty small, just enough for men to crawl through and stuff. So they couldn't use what the Army normally had as a big pick. So their blacksmith that was in the unit had to take their picks and file them on down so they were a smaller pick so that they could swing them. Now down at the battlefield, there is a museum down there, and they have some of the artifacts still from this battle and stuff. And that's a picture of one of the picks that was left that's down in their museum. This is the timbering part now. This is the mining engineering part of this with the timbering and stuff. In the anthracite region, we count the number of pieces, so we call this a 4-piece timber set. This is the collar up here. This is the 2 legs on each side to support the collar. And then on this case, this is a mud sill here. So that's how they started timbering. Now they needed wood to do this timbering. And again, they got no help whatsoever. So they had to take men from their own unit, and they found a bridge that was probably a Confederate bridge nearby. They tore it apart just so that they have wood to start this project. Later on, they found a sawmill, and they used the sawmill, and the sawmill was kind of in no man's land. They had no protection. There could have still been units of Confederates around there and stuff, but they took their own unit and they cut their own wood, and that's how they made their wood for timbering this mine. Now here's a slide that I show. This shows you about counting the pieces and stuff. This is a 3-piece set now. This is like you're looking in a hallway here. They didn't need a mud sill right here. It all depends on the strata and what kind of geological conditions you have. This is a 2-piece set right here that they're supporting the roof, and they just need one prop here to hold it open. Now, if you have a good hard rock, usually slate, sometimes conglomerate, on the top or the bottom, you can get away with a 1-piece set because the roof and the structure of the roof is going to hold up for you. And this is also a 1-piece set, but it's on both sides looking straight in on a flatter pitch. In the anthracite region too, then when they mine, they have what they call chutes. They use gravity when they blast the coal to bring the coal down through the chute. And then underneath the chute, they'll have like a small railroad car to load the coal onto and stuff. So this is all methods that are still currently used in the anthracite region. Years ago, we had many mines. As I speak right now, we only have 3 active deep mines left. Back in 1963, there were almost 800 mines. When I came out of college in 1980, there were about 180 deep mines. Now we're down to 3 deep mines. Now, this is one of Pleasance's sketch. Right before they got to their trenches and stuff, they had to come up with a shaft for the air. And this is a sketch of it. It's about 30-some feet from the top to the bottom here. But you guys as geologists should notice something here. In his drawing, the way he sketched it, there's a change in geology at this point right here, and then up to here, up to this point. One of the things that really helped out with what he did here and stuff, as you went farther, well, from the top down, it was very sandy, but as you got down farther, it was more like a marl and a clay. And that was helpful for them because they could dig and pick by hand through the clay and stuff, but when it came to the sand, it wasn't going to happen. It's just too hard to hold up the sand. The other thing that really helped them out with was the Confederates were starting to get an idea that, hey, they might be tunneling towards us here and stuff like that. So they started sinking counter shafts. But when they sunk the counter shafts, they were encountering this sandier material up near the top here. And they figured, well, there's no way that they could hold it up. So they kind of gave up on it stuff, figuring that it was all sand all the way down to the bottom, but it wasn't. It was clay and marl. This drawing also shows the furnace here, a grate here. From what Pleasance had learned with the railroad, he had learned that if you make a fire, you, what they call vitriate the air, heat rises. So when heat rises, it starts to create a circuit. And there's actually 3 things in engineering here that use the same formulas: water in pipes, electricity, and air. They all have friction to them, they all have velocity to them, and they all have quantity to them and stuff. So by heating the air and vitriating the air, he was creating a circuit. And right here is what he called an air box. He took some of them planks and he made like a square pipe, you could call it, out of it and stuff like that. And he set the pipes there at the beginning of the tunnel and stuff, and then set that shaft like that and stuff, so that air would come in that box to the face where they were working and then return out through the shaft. Now, excuse me, he had to have a fire going. Now, the Confederates were going to see if there was a fire going and stuff. It was like smoke rises too, and it gets it in the atmosphere and stuff. So what he did is all the way down the trench line, he had everybody making fires. So even if they thought there was a tunnel coming, they couldn't tell which fire it was that was ventilating this mine. So he made that work too.
So where is this shaft relative to the tunnel entrance?
That other drawing had it. I would say it was probably about maybe 80 feet away.
Okay.
This is a drawing that I threw in here just to show the fact about heating air with a fire in the mine, that it draws air because heat rises. And that's the basic principle that he used to create that current. Now, in the anthracite region, they began using that kind of method. And this is a picture of where they had one of those that they actually built a stone chimney, you could call it, that goes way up in the air so there would be more lift and more draft to it stuff. This picture was taken near Tamaqua, and if you see at the very bottom of the ground level, here's a fellow standing here. So you kind of get an idea how tall that was. And down on the battlefield there and stuff, they have different diagrams and stuff that shows the ventilation. Here's the entrance of the mine, and they have the plank coming in here like tubing and stuff, ventilating the face, and then making a return this way. They had to put a brattice up here so that the air wouldn't short circuit and go back out the mine then. And that's a picture looking in from the other picture I showed you at the mouth, and you can see the wooden tubing that they have showed right there. Now, our current deep mines and stuff, they have to have what's called a mine opening plan. How are they going to support their mine? How are they going to ventilate their mine? Things like that. This is one of the drawings that shows how the air comes in our mines still and comes around and it makes a circuit just like that. And we're back to the principles of air, water, and how all of those work the same way. Now, there was a study done here about 10 years ago or so down at the site, and it was done by William and Mary College, and also they teamed up with the Virginia Division of Geology and Mineral Resources. And they went down there to actually map the different strata that we had looked at from Pleasance's drawing. And you can kind of see on the drawing, they smeared up some of the material here on their notebook and stuff. And you can see that. This merle that they came across with, it was almost like putty. And there's some stories here that some of the soldiers, they would take it and make bowls or smoking pipes and things like that. They could actually make things out of it. Stuff. And that is the picture that they came up with from their drilling. They categorized all of it. You can kind of see in the picture here how it's finer. The description talks about the sands that are in it and how you get down as you keep going deeper, how it turns into a harder clay. And this is a picture that they drew up of their cross section of the different formations they came across. Now, this came in, it was surveyed. You can see right here is where the shaft is at on the drawing. There's the end of the Union forces here, and over here is the Confederate forces. They came in so far, and they got to a point right here where it was starting to collapse off. And I'm quite sure that Dwayne from the Army Corps of Engineers was probably laughing at him at that time and saying to him, I told you this won't work. But there's a lot of ingenuity in the anthracite region. So we have a method, what we call long poling here. And what long poling is on this diagram here, we're going, this mine is working to the left here. What they do is they set up mine props where the roof is solid, but then they drive props in that have wedges above that. It's kind of a cantilever effect. And with the cantilever effect, then it makes it safe that any kind of material as it was collapsing, they can clean it up. And when they had that collapse going and they almost lost it, that's what they did. They did this kind of a method to try to clean that up and support it. And then at that time, Pleasance decided he was going to go upgrade a little bit harder. Another thing that helped them out here is he was driving from a lower point and putting a slight grade going uphill. As he hit springs and he hit water, he had drainage. The water could come out of the tunnel. And that's kind of his simple drawing that he drew and stuff like that. You can see the main gallery coming. He jumped out of the merle a little bit, got into this, and kept on driving underneath the Confederate rebels' fort. You can see he is sand and clay, merle, underneath the clay again. And that's a cleaned up version of it. But on that cleaned up version, here's a plan view looking straight down at it. As he got to almost underneath the Confederate fort, he went out in galleries that were about 40 some feet on both sides. That's a little bit of a blow up of the galleries right there. And each one of these squares is where he set up a component there with the black powder that they used for the explosion part. Now, this drawing also shows something on a mining engineering part that's really important, and that's right here where he has it labeled end of tamping. They needed also wheelbarrows to bring this material out. Again, no cooperation. So they had to take cracker barrel boxes and put handles on them. They called them barrows and stuff, and put the material in those barrows, and they had to be hand lugged out of the mine just like that. But there was a lot of material that was involved here and stuff, and they didn't want to key it off to the Confederates. So some of the material that came out got covered up with shrubs and brush and stuff like that. But some of the material that came out got put in bags because they knew they needed that in bags later on. And that's why this drawing is so important. In mining and setting a blast off and stuff, miners, they drill a hole, they put a stick of dynamite in, but then they tamp it with a bag of dirt or something, and they seal that hole off. If they didn't seal the back of the hole off and the dynamite went off, a lot of the force of the explosion would just come right out the hole. You want to pack that tight and stuff like that so it creates that it's going to fracture everything around it and not lose the strength of your dynamite. So in this case, then when they had their black powder in there, they took the bags back in and they set them there as a barrier and stuff for when the dynamite or the black powder went off. And they took those bags back to this point right here. So now this was tamped like you were a coal miner setting off a blast. It was tamped, and the Confederates weren't no wiser to it. These are the magazines of the squares that I showed you. They're kind of smaller at the bottom, bigger at the top, so that the blast would have more force coming up. That's a picture of some of these guys carrying the black powder in. Now, originally they wanted 12,000 pounds of black powder to set this off, but the Duane and the higher ups would give them 8,000 pounds of black powder. At this point in time and stuff, they weren't sure what 12,000 pounds of black powder was going to do, and they were concerned that this blast might actually go up and start coming back onto the Union side. So they didn't want to cover their own guys in rocks, flying rocks and stuff if they used too much black powder. So they settled at 8,000 pounds of black powder. And this is a picture of them carrying black powder into the mine to those magazines. There they have it in bags. Some of the pictures have it in kegs. But one of the things I like to point out is when they had this mine all set up and developed, every 20 feet they had a candle for lighting. Can you imagine carrying 50 pounds of black powder right next to a candle? And somehow, unfortunately, none of it went off and stuff while they were carrying it in there and stuff. And there's another picture at the end. Here you see the end of the tubing for ventilation. This is an artist rendition from years ago. Here they have kegs in there setting the black powder inside those magazines. And just here's another picture of what it looked like. When the blast went off, they figured it was almost 300 feet this way, in a longitudinal direction, about 50 feet that way, and somewhere around 25, 30 feet deep. When they got underneath the Confederate fort, they could actually hear the men, and they could hear things moving around. But sound works really interesting and stuff. When you're underground, you can hear the stuff above you. But if you're standing up on top, you can't really hear what's underneath you. I've had that experience already in some tourist mines where we helped develop a new air hole and stuff like that. It's kind of interesting. So, some statistics so I don't forget them here. The excavation of the tunnel began on June 25th at 12 o'clock, and the tunnel was completed on July 23rd, 1864. There were a total of 210 men. They worked around the clock. They usually had two guys inside working at a time, and it just switched off. This is the next important person in this whole story here. His nickname was a Snapper, but his name was Sergeant Henry Reese. He was from Cass Township and close to the town of Minersville. He was in camp. He was like the superintendent of this operation. He had mining experience. He had come from Wales. He settled in Minersville. He was involved in mining operations around Minersville, but he was the main superintendent to make sure everything was going to work. On the film, when you seen the fellow coming out of the mine and it said 48th on the cap, that was supposed to represent him. That's a picture of him right there. One of the few pictures that's still around yet. We're going to talk about him a lot more here yet. So the main tunnel was 511.8 feet. So we know from mathematics and stuff that Pleasance was carrying his calculations out to at least a tenth of a foot. So when I mentioned about the GPS and stuff like that, he was using up to a tenth of a foot in his calculations. And the right lateral was 38 feet. The left lateral was 37 feet. So there was a total of 586.8 feet that those men picked and shoveled and got out of there all by themselves with their hands. The height of the galleries was around 4 to 5 feet, and the width sometimes around the bottom was about 5 feet. So there was a total of 18,000 cubic feet of material that was dug out of that tunnel. And that tunnel was going to work down there, but places like Gettysburg and stuff where the material, the rock is, that would never happen there. But here was the ideal place to do this. So here comes the next thing. Colonel Pleasance, he requested one long fuse, but he was given pieces. And then he was given the 8,000 pounds of black powder to put in the magazines. And the battle plan called for the mine to be detonated between 3:30 and 3:40 a.m. during darkness of the morning of July 30th, 1864. And Colonel Pleasance lit the fuse personally himself. Now, since he was given sections of fuses and not one long fuse, they had to knot them together. So the blast didn't occur. So they waited a period of time, and Sergeant Reese automatically volunteered to go in and see what happened. And there was another fellow that was involved, Lieutenant Dowdy, who lived in a town called Cressona, just south of Pottsville. They volunteered to go back in. Now, some of the records say that their bodies, of them two men, Reese and Dowdy, could have been turned into atoms if the blast would have gone off while they were in the tunnel. They had no idea. It could have been smoldering and ready to go off and stuff like that. But to me, that's one of the bravest acts. Them guys knew the dangers of mining, and they volunteered. We're going in to make this happen. And that's a picture of Dowdy from Cressona. So they discovered that the fuse had burnt 50 feet of the 98 feet length that had gone out. So they only had half of it left. So Sergeant Reese had to go back out to get a pocket knife to go back after the fuse. He re-entered the mine, he re-spliced the fuse, and he lit it. And you can imagine crawling on your knees. Hey, this is 510 feet. Think of a football field. This is a football field and 2/3 of a football field. To relight a fuse that's only 50 feet, he barely got out of the mine. But the blast went off. It's up to that point in time until the atomic bomb went off. It was considered the largest blast in warfare. And all this, again, is just from a local coal mining unit, the 48th from Pottsville. And they made all this happen. So finally, at 4:44 a.m. on July 30th, the charges exploded. There was a massive shower of earth, men's guns. You've seen it on the video and stuff. And basically, the crater measured 170 feet long here. And it was 100 to 120 feet wide, at least 30 feet deep. And when the blast went off, they figured between 250 and 350 Confederate soldiers were instantly killed at the blast, along with several cannons that were there at that fort. The hole was open. They were ready to go into Petersburg and stuff. The Confederates, a lot of them just abandoned their spots and just didn't know what happened. They just left. But that part I don't go into and stuff. That's the battle part. The battle went so horrifically bad because of leadership and not following plans. And basically, some of the units did go around this crater and they were waiting for the command to tell them to go into Petersburg, and most of their command was behind the lines and never gave them the order to go into Petersburg. So that's another artist's rendition of what the battlefield looked like at that time. And this is an interesting picture because after the battle went so horrifically bad, they asked for a truce, a one-day truce to clean the bodies up on the battlefield. And part of the truce was they had to have an officer from the Confederate side and an officer from the Union side be there the whole time and basically stare at each other. So I think somewhere right about in here is the two officers staring at each other while they were cleaning the bodies off the battlefield. And General Grant at the time, he said it was the saddest affair he ever witnessed in the war. It would have ended the war right there. They could have went right into Petersburg. They could have took out the railroad. The war would have been over. Like I had said before, the war lasted about another year. Thousands of soldiers on both sides were killed. We'd be kind of living in a different world if all them people had lived. Now, here's the next interesting part about this and stuff. Colonel Pleasance, this was his idea to do the tunnel. He did the engineering and stuff, but if this was ever made into a movie or anything like that, there's two key people here and stuff. The second one is Henry Reese. And after the war was over, Major General John Parks put in for him to get the Medal of Honor. His body could have been turned to atoms and stuff. Part of the Medal of Honor is, you could get killed and stuff like that. And he knew it, and he still went in and did it. So they put in for him to get the Medal of Honor. And there's the actual paperwork and stuff that was filled out. Henry Reese right there. And they explained right here in cursive writing what he had done and signed it. And he never got the Medal of Honor. Paperwork was lost for some period of time. So he was born July 5th, 1835 in Monmouthshire, Wales. He lived in Cass Township. He married Elizabeth Combs from the St. Paul's Church. He worked in the local coal mines, and he enlisted on April 21st, 1861 with the 48th Pennsylvania Infantry Regiment at Minersville. He was discharged then on July 17th, 1865. He moved to Shamokin after the war was over. He became the chief of police. He was the chief of police at the time the Damali Maguires were starting up in history. He was also a close friend of Captain Jack Crawford and William Buffalo Bill Cody. Used to come visit him because he operated a saloon in Shamokin, and he was the chief burgess, and he was a member of the Lincoln Post 140 from Shamokin. And ironically, he died of a tooth infection on May 3rd, 1893, and he's buried in the Shamokin Cemetery. And there's his record of death, and right here you'll see it says abscess. When they had his funeral service in the city of Shamokin, even until this day, it's considered the largest funeral service that was ever attended. He was so well liked. And there's his tombstone. Not a whole lot of people know about it and stuff, but there's his medallion for the Civil War. And on the engravement, it's hard to read here, so I did an etching. And I think some of the words on there are the most beautiful words I've ever read here for a veteran. The hero who touched the fuse at Petersburg, Virginia, like stars that sink out to the west, one by one we seek our rest. Let glory's wreath rest on the warrior's tomb. Let monumental shafts surmount his grave, for all the world yields homage to the brave. I think that really hit it. So I've done this presentation quite a few times before, and we're working on trying to get him his Medal of Honor posthumously. And one of the programs I did is I met a great-great-nephew. When you do a posthumous Medal of Honor, it has to be a direct descendant. And I said, you're close, but not close enough. But he did have some information. I was able to do a little bit of detective work. and actually found the living relatives, the great-great-great-grandson and so forth, living in a town called Healdsburg, Pennsylvania, near Knoebels Grove. And I had somebody look in the phone book for the area and stuff, and their last name changed to Lickdale. The men died out in the family, you could say. The women carried the name on and stuff like that. Their name was Lickdale. So I had somebody I know look in the phone book for the Shamokin area, and they found 2 Lickdales, and I got the number, and I called up, and at first he thought I was a wise guy and stuff like that, who'd be calling like that. But finally I convinced him, yeah, and when we got together and stuff, and the family still had some items of his. This is considered a regiment medal. And it says Lieutenant Henry Reese, because they promoted him when he got out, the 48th, the man who blew up the fort in Petersburg. And this is a letter that Dan Muser wrote in 2022 to try to get him the Medal of Honor. We had to go through a certified genealogy research and stuff like that, and have it certified, and a lot of other things and stuff like that. And we sent it in, and it got denied. It got denied. But we're making a second attempt at it right now. We didn't have enough guts into the paperwork to make it happen. And since then, I've found some more things. Actually, because the battle went so bad, Lincoln ordered an inquisition, you could say, and he had all the officers appear as if they were in court, swearing to tell the truth, the whole truth, and nothing but the truth. And some of their testimony does talk about Reese and what he did. So to do a posthumous Medal of Honor, you have to have a witness to be able to witness what the person did. How are we going to do that back in 1865? But with these sworn in statements, we think we have enough information to go back at it and try to make it happen. That's some of the paperwork that they had. Somebody else had tried to look into this back in 1915. And there's what a Medal of Honor looks like. And it talks about that the person is risking his life in the call of duty, personal bravery and self-sacrifice so conspicuous as to clearly distinguish the individual above his comrades. If back then they were saying his body could have been turned to atoms, that's a pretty strong statement there to go along with that. And ironically, I found a newspaper article that was written in the Sunbury paper, the Daily Item, back on July 3rd, 1896, that the Congress had struck a medal for him, the Medal of Honor, and they had contacted the family to see if the family was willing to accept it, because then they found his paperwork. They found his paperwork after he passed away, and they were willing to give him the Medal of Honor, but something happened. It never happened again. The family didn't get the Medal of Honor. So here's a couple pictures of what was left after the battle. You can see part of the mine right here going into the crater part. And it kind of became a tourist attraction. There's another part of the timbering there. And you can see the women with the dresses on. It became, like I said, more and more like a tourist attraction. And actually, the town of Petersburg honored him after he passed away and stuff. They made a tribute to him. And in the 1930s, they dedicated the grounds and stuff. It became a federal park. And they had people presenting and speeches made and stuff. And there was one officer from the Confederate side that came, and he said his statement was in his speech that the Union thought this was such a disaster with the battle part and stuff like that. But he said, actually, this was really bad for the Confederates, because after this blast, the desertion rate for the Confederates went through the ceiling, because they figured, boy, if them Yankee guys can blow us up like that and stuff like that, I'm out of here. And that was his testimony. So there's the grounds again, grass growing. You can see the subsidences that are still left yet. And there's some of their monuments of explaining how they did it. And Henry Pleasants, he's buried in Pottsville. He's buried in the Charles Baber Cemetery. So it's kind of interesting that two heroes of this battle are buried in key cities of Schuylkill County, Pottsville, and Shamokin in Northumberland County. And also with Henry Pleasance's funeral service, it was the largest funeral ever attended to this day, too. So that's interesting. But his tombstone is very simple. He died of a brain tumor in 1880. About a year later, medical procedures came that they could have probably saved him, but he passed away in 1880. And his just simply says, "Until the day breaks and the shadows flee away." And that's it. So that's Colonel Pleasance. And that's my last slide. And I hope you enjoyed it. Thank you for having me.